Okay, so we're on to the last part now of projectiles, which is 6D. And what we're going to do here is we're going to come up with some general equations for projectiles. There's nothing that's brand new in it. We're just going to look at sort of a couple of situations where when we write out SUVAT, we are able to sort of come up with some pretty powerful results. So we're going to have a particle that goes from a point on a horizontal plane at a velocity u, an angle alpha, moves freely until it hits B, which is also on the plane. So the sketch would be something like, something like this, okay? And that initial one there is called u, and that angle there is called alpha. And we're looking for an expression for the time of flight and the range. Time of flight means how long is it in the air until here. Range is going to be this distance. Okay, so let's get to it. I'm going to start by writing my SUVAT. And yeah, we'll do just DST as well. Okay, so for my SUVAT, if I'm talking about when it hits the plane again, I'm going to go with a 0. For the launch, remember we've done it a few times now, we talked about breaking this up into a vertical and a horizontal. So this is u cos alpha, this is u sine alpha. So I'm going to put these down here. So I'm going to say this is u cos alpha, this is u sine alpha. I could write minus 9.8, but we're going to write it in terms of g this time. So I'm going to write minus g. So again, as per pretty much always, I've made up my positive direction, haven't I? And what's the goal here? The time of flight. So let's just call this sort of t. Now, anything else I want to do, I think that's fine for now. So I've got 4 bits of information. Let's put them in a SUVAT. So s equals ut plus half at squared. Means this is now going to become 0 equals, I'm going to write this as ut sine alpha minus a half g t squared. Now, I know that at t equals 0, that's the start, yeah? So what I'm going to do is I could factorize the t out, is one way you can think of it if you like, or I can just divide everything by t is also a way of doing it here, because I know that I'm not interested in that value. Right, what do I do from here? Well, I suppose I just rearrange, don't I? So if I add this to the other side, I'll get half gt equals u sine alpha. Is that correct? Yeah. And then I could write this instead as t equals 2u sine alpha over g. Okay, so that's it for my expression. Now, what's powerful is, remember again, that t is that t, isn't it? So if we want to know what this part is, well, it's actually quite simple. It's just this same t from before, but written like this, times that. Okay, so I'm going to say then that the distance, the distance, here I mean the range, okay, the horizontal distance, is equal to u cos alpha times t, which is u cos alpha multiplied by all of this stuff here. So that's 2u sine alpha over g, okay? And then we can start to manipulate this a little bit. So let's call this u squared. I'm going to just do that. You're going to see why in just a second, okay? U squared here. And then I'm going to leave 2 sine alpha cos alpha. Checking my work. Yeah, I think I'm happy with that. So can you spot it? Last chance. Can you spot it? Did you spot it? Yeah. This one here is the double angle. Okay, this is the double angle for sine. Is actually the same as sine to alpha. So here's the really neat, really cool answer. It's u squared sine 2 alpha over G. So how cool is that? Pretty cool. That if we have a projectile going from ground to ground, we can do that. There we go. That's the first half, okay? So you may be asked to derive them. All it is you just write down everything as you normally would, work through it, use SUVATs when you've got 4 pieces of information, and you'll be absolutely fine. Okay? So we're going to have a go at a couple more. Again, they look intimidating at the start, but just go with it. So let me just check. Yeah, this is the next one we're proving. Good. Okay, so we've worked through a couple of those. Now this one is a bit scary, but like I said, you'll be fine. So a particle is projected from speed u, angle alpha, right? The thing that's not obvious about this one is going to be about using x and y, okay? If we use x and y, we can put them in that formula there. X is horizontal distance, so that's like the range then, isn't it? Y is the projection. So yeah, let's get into it then. So show this result here. Okay, so first thing we're going to do is dst. So we're going to do our dst and our SUVAT. Now, what's not obvious about this one is we're going to call this one x and we're going to call this one y. Okay, and we're just talking about in general where something would be. So this is going to be u cos alpha again. This is going to be u sine alpha. This is going to be, is g involved? Yes. So this is going to be minus g. Let's look at the formula to see if there's any clues. So I've got y, I've got x. Tan, well, tan's from sine and cos, isn't it? This one's a bit tricky. We'll see where that one's from in a moment. Okay, so the thing is I can't see the letter T anywhere. And that's interesting because T is the only thing that carries between them. So I think it's been eliminated. I think T has been eliminated. Like it's been used to chain these equations together, I think is what's happened. So I'm going to do a SUVAT over here with the information I have. Why not V? Well, I don't know anything about V and it's not in the question. That's why I'm not using that. So if I write this one down, I get y equals u sine, I could write ut, u sine alpha times t or something like that, minus 1/2 gt squared. Yeah. At the same time, I could write one for this as well, which is x equals, isn't it? So let's do x equals those things multiplied. So ut cos alpha. Okay. Now, I kind of gave you a clue a minute ago, which is that t is not in the final answer. So what we're going to do, because this says y equals, and it has x involved as well, we're going to get this t on its own. So let's do that. So t will be equal to x over u cos alpha. Okay, and then we're going to sub that into these parts here. Okay, so let's do that. Let's say then that y equals u sine alpha. I'm going to put it in brackets, I think, make it less confusing. U sine alpha x over u cos alpha. Yeah. Minus 1/2 g, and then all of this squared. So x over u cos alpha squared. Lovely. And believe it or not, we're getting quite close. So it's a bit of cancelling here. What does this turn into? This is sine over cos. This is x tan alpha. Yeah, there you go. X tan alpha. So that's y equals... Now this one we're going to do in a few parts because this is much, much less obvious. So minus 1/2 g x squared over u squared cos squared alpha. And I'm going to, hang on, what's my final answer? I just need to keep an eye on my final answer at this point here. So the half and the u squared can go together. Okay, right. Let's write it like this then. So let's do, these go together, they're on the top line, right? Imagine this is like over 1 or something. So gx squared over 2u squared times 1 over cos squared alpha. So check that that's correct. If you multiply it back, it should take you to an equivalent statement. So yeah, I'm happy with that. And now just see, we're just left with this thing here. So how to do this? Well, that's x tan alpha, y equals. So the final thing that we're going to do is we're going to realise that cos squared is the same as something else, isn't it? What's cos squared the same as? Well, because it's in the denominator, it's the same as sec squared, okay? So this is the same as sec squared alpha, okay? And then I'm just going to do the next bit here, which is to say that sec squared is 1 plus tan squared alpha, okay? So that's where that final bit comes from. So I'm going to write it. You wouldn't need to write every single little bit of working out here on the left like I've done, but at the end, it should be nice and neat and nice and clear. So that's how I've derived that result there. Why would you want tan? Well, this is already about tan, and this is about tan, so it's sort of convenient, no, to have only one trig function. And the last bit here, what are we meant to do on this? Okay, the last bit is actually not a projectile formula question. The last bit here is actually just using the results, okay? So you've got a speed here. So speed, this is your u figure, isn't it? You've got alpha there. You've got an x value. Okay, you've got a y value. So all you would actually do for this one here is sub it into the formula that we've just done. So if you sub it into this formula here, you should get 8 equals, because it's above, 32 tan alpha. So let's just check that follows so far. Yeah, I'm literally just subbing in the values, aren't I? When you use g as 9.8 and u squared and all of this sort of stuff here, this should turn into minus 6.4, 1 plus tan squared alpha. Okay, and this is a quadratic in tan. So you can sort of expand it out, get 0. Eventually you'll get to 6.4 tan squared alpha minus 32 tan alpha plus 14.4 equals 0. And it's a quadratic, okay? So it's the same as doing something like 6.4 m squared minus 32m plus 14.4. Yeah, if you do a substitution, it's really easy to see. So if tan alpha is m, you get that one there. And eventually you will get m equals 1/2. And you'll also get 9 over 2. So tan alpha equals 1/2, or 9 over 2. And in degrees, you get 27.7, or 77. And it's brought up that this is quite an interesting result. It's an interesting result because it shows you that there are 2 different angles that you can launch at that achieve these values in the question. Okay, there we go then. So I'll just talk through these final results. You're not expected to memorize them, but it's good to have some awareness of it. So time of flight we worked out in the first question. Time to reach the greatest height, we didn't actually discuss this, but the idea is that this is half, right? Because all these examples, this is a key point here, all these examples that we did only work for ground to ground. So the entire journey was this. Well, because it's symmetrical, the midpoint up here is half of the time. Okay, so that result there, you can just sort of use half of the one from before. The range, we went directly, I think we went directly from that to that one there. And then the last one, you have to use y's and x's to prove these ones in general. Okay, but they're generalized formulas for when you have projectiles from the ground to the ground. Yeah, I hope you found that part there quite good fun.